Hi, I'm Elise Naramore, and we're going to go through Learning Progression 7, which is about interpreting graphs. So, graphs are not pretty pictures, right? So, you have to be able to interpret them. Why? Because you're going to see them no matter what your field of interest is. It would be really helpful for you to know these common graph shapes and their names. This is not all of the possibilities, but these are the ones that we will see in this class. Knowing their names, the correct names for each shape, and knowing the general structure of the trendline equation will make your life so much easier. Features of a graph include the x and y coordinates, the shape of the trend line, the equation of the trend line, being able to write a mathematical model, understanding what the correlation coefficient is. That's really helpful when we do lab reports. And also occasionally we'll use area under the curve. We have this hierarchy of evidence, and I've also talked about this in context of lab, where there's stronger evidence and then there's weaker evidence. And so when we are looking for strong evidence, generally we're looking at the mathematical model. Weaker evidence are qualitative observations, coordinate pairs, things like that. That doesn't mean they're wrong. It doesn't mean they're bad. If all you can do in a particular problem is use a coordinate pair, then use it. However, if you can use the mathematical model, then you should use that. You'll notice that area under the curve is not on here. Area under a curve is strong evidence when that's what's appropriate. Here's the copy of the rubric for this learning progression. So I'm going to walk you through. Please remember that if you are currently at developing level, you want to watch this video until I talk about proficient, right? Listen to proficient, that's your target. And then you may want to skip ahead and get to the strategies and the example at the end, and then revisit this video when you're ready to move to advanced. Sometimes when you're not ready, watching the achievement levels, the information about achievement levels that are above where you're currently at make things very confusing. So feel free to pause or skip ahead. So that's what we're going to do right now. Beginning level, qualitative explanation. Just look at the graph, describe what you see. I see that this, the graph has this on the X and this on the Y, and it's a straight line. Just describe what you see. At least I know you're looking at the graph. Developing is now you're actually identifying a feature of the graph. In our class, generally that's going to be a coordinate pair, and better would be the equation of the trend line and or the mathematical model. So if the equation of the trend line is given, state that. If you want to pick a coordinate pair, then state that. So you're going to use that to answer the question. For proficient, you're going to overtly use those. That means you're going to the graph, you're picking a point, you're labeling it X, Y, right? You're actually put the numbers in, right? And you're going to communicate like, here's what I'm using. Please make sure when you're picking a coordinate point that you're picking a point on the trend line. Remember, these are best fit lines. So a data point may be off the trend line. You cannot use that. The data point you choose must be on the trend line. However, better yet, if you have an equation of a trend line, write your mathematical model. Use that to answer the question asked. You may make mistakes in the mathematical model and still earn, let me say that again. You may make mistakes in applying the mathematical model, but as long as you answer the question, even if the answer is wrong, you can still earn proficient. However, if you identify a point and use that to answer the question, that must be right. Okay, otherwise that'll be developing. Advanced means you're going to now overtly communicate what theory you're using. It could be in words. It might be in symbols with like an equation. Then you use the mathematical model for sure, and you do that correctly by comparing the mathematical model to the theory. Okay, you can have an error in your solution, but not in the process of doing it. Okay, the answer should be correct. And then expert level is It might be a multi-step problem. It might be a multi-unit problem. It may be something more sophisticated like a linearized graph, something like that, where again, you're using the mathematical model to answer the question, unless it's an area under the curve situation, which may still be the most sophisticated manner that you can, the most sophisticated evidence you can use, and then that's fine. All right, so here's the strategy. First, start by looking at the graph and describe it. There is whatever relationship between this variable and that variable. Find an equation on your equation sheet that includes those two variables. Sometimes you will derive it. Sometimes it's from a previous part of the problem where you had to do the problem solving process. Overtly identify the feature of the graph. You can just simply say, I am using this point, or I am using this mathematical model, or here's the mathematical model, or here's the equation of the trend line. Do it overtly. Pretend I'm a dummy, okay? And then there's 3 different methods that you can use. If you're going to use the equation of the trend line, do method 1. If you're using the coordinate point, do method 2. If you're going to do the area under the curve, you're going to do method 3. So read those over, and then you can pause, and then we're going to go try a problem or 2. The period of a simple harmonic oscillator is the time it takes for one complete vibration. The period t depends on the mass as well as the spring force constant as shown in the equation above. Use the graph to determine the spring force constant. So listen, why am I doing problems that we haven't covered in class? I want you to see that these techniques work whether or not you know the information, whether or not I've taught it to you. So bear with me here. Because this means that it's unfamiliar for everybody, and you can still apply these strategies. So first thing you do is you say what you see. So, ignore that I already identified a point. We're going to get to that in a little bit. But you want to look at, this is a period versus mass graph, and there's a direct square root relationship. How do I know? Well, it has that eyebrow shape. That's why it's really good to know those common graph shapes. If you weren't sure, you can also look at the exponent here, right? That 0.5, it's not exactly 0.5, but an exponent of 0.5 on your x variable tells you it's a direct square root. Again, that's why I want you to know those common graph shapes. All right, so now method 1 is using the mathematical model, which was already given on this particular graph. So just write that down. And they also, in the story, they gave you the theory. So you write that down. Now you want to get that theory into the same format as your mathematical model. So you just want to rearrange it so that m is by, m to the 0.5 is by itself. So I'm going to do that. I just separated out the square root of k and put it in the denominator of 2 pi. It just makes it nice and neat. And now I can line that up, and I see that the periods are under each other and the square root of m is under each other. So then what's left? I've got this 0.8868, right? The coefficient in front of the square root of mass. Therefore, that's got to be equal to what's left over in the theory, the 2 pi over square root of k. So I can just set those equal to each other. And now this is just algebra. I could solve for the square root of k. So now I just divided both sides by 0.8868 and then multiplied both sides by square root of k. And I can take the 7.085 and square both sides. And then I end up with a value of 50.2. So that's my spring force constant, and that's pretty exact. The second method is using the point, which I identified already up here. Notice I used a point on the trend line that isn't a data point. That's perfectly fine, right? As long as you make a good estimate. That's not 0.35 on the y-axis. It's a little more. You might have decided that that was 0.367 or 0.38. That's all okay. You're allowed to guess differently than me, but you have to clearly communicate what point you're using, and it needs to be reasonable. It should be more than halfway. All right, so what's next? I have this point, right? And I'm going to explain what this means. It means that there's a mass of 0.2 that creates a period of 0.375. Again, you would have different numbers. You could use any point you want on that line. You could use 0.8 and I don't know, what is that, 0.75? You know, whatever values you want. Then you're going to write the theory. Then you're going to plug the numbers in. Then you're going to solve. So do the algebra and you can get your K is 56.1. Now this is not as exact, right? You'll notice it's different from the previous because using a point isn't as accurate as using the equation of a trend line, because a trend line relies on all the data points as opposed to just using a single point. So that's how you can do either way, but the maximum you can get with method 2 is proficient. The maximum you can get with method 1 is expert. So I want you to learn how to do method 1, but if you're really struggling, then definitely do method 2, because at least you'll get up to proficient, which there's nothing wrong with that, but I'd like you to try. Okay. Let's talk about method 3, which is using the area under a curve. Here's a different question. 2 springs, a red and a blue spring, were stretched to a variety of different lengths, x. The force needed was measured for each stretch distance, and the values were graphed as shown to the right. Which spring requires more work to be done? Now, this is a content that you already know because we did energy, right? This is asking about work. So when I say work, well, what do you think of? Well, I would first, again, we're going to identify what we see. This is a graph of force versus distance showing a direct relationship. And since they mention work, I'm going to write that down because that's the theory I need to use. I have to figure out what work is. That's force times distance. Now, you could, I guess, pick a point, but that's not going to be as helpful in this case. So think of like, okay, if that's not going to be as helpful, then I can figure out, oh, the area under the curve is work. How do I know that? Because if you look here, right, this triangle, the equation for a triangle is 1/2 base times height. And if I put in the variables where the height is the force and the base is distance, or x, well, then I've got 1/2 of the force, that's the average force, and then I've got distance. So force times the average force times distance is work. So that's, so you can just pick your last point there. That's what that, right? You figure out, okay, what's the maximum force? What's my distance? And then I can do the math. I get 0.24 joules. Now I'm going to do the same thing for the blue triangle. See, there's the blue triangle. So the area of the blue triangle is 1/2 base times height. I can put in force times distance again, and I'll get 0.48 times 1, right? So that's this. Oops, didn't mean to do that. That's the x is 1, and then if I go across, I'll get 0.48, and you'll notice that I get the same 0.24 joules. So then I can answer the question, which is that the areas are equal, therefore the work done is equal. So that's one way to do it. Another way to do it more qualitatively is to look at the size of the triangles. You might be able to do it visually, but that's still using the area. It won't get you all the way to expert like this might, but you do want to, because you really want to show your work. So those are some strategies for figuring out the interpreting of a graph.